Welcome back to Cloud 42, I'm James. Today we're going to continue work on the motor clamp for the Toolpost grinder. If you remember last time, we milled the top side and the perimeter of the clamp holding the stock in our shop-made TalonGrip vise jaws. Now we need to flip the part over and mill the other side, and that's going to require us to carve a set of custom soft jaws to hold the part. Let's get those soft jaws mounted up in the vise and get started. Okay, we have a set of soft jaws in the vise now, and these are 1 by 2 inch by 5 inch long soft jaws. We made these in a previous video if you want to go check that out. And in order to carve these so that they'll fit the part, let me grab the part. We ultimately want to carve these so we can drop this part in and it will grip them. It'll grip it. Now, to do that, the jaws can't be together or there's not enough space. Jaws have to be 1.25 inches apart. So to do that, I'll grab some parallels. Now we want to actually clamp it up high so that if there's any rocking in the jaws, that happens for the cutting. So we'll drop a couple of 1-inch parallels underneath, and it needs to be 1.25 inches. So we got 1.25 inch parallel that we can drop on top, and then we can just clamp down on this. And that'll put these two jaws 1.25 inches apart. Now, these are loose. I'm just going to pull them out. There's no sense trying to tap it down because we're not trying to machine that part. We're just going to machine the top of the soft jaws. Okay, the first thing we need is an edge finder so we can locate the world here for the mill. And we're just going to locate off of this corner, and so we can just use the offsets tab in Mach 3. And there's the Y0, or the Y.1 since it's the 200,000th edge finder. There it is. There's the X.1. Now I'll grab the 10,000th shim. And let's find our Z0. There it is, and it's our Z height of 0.1. So we're good. Now we can grab a 3/8 inch end mill and carve out these soft jaws. Okay, this looks great, but based on what I learned from last time when I milled out the actual motor clamp itself, I'm going to go ahead and run that contour pass a couple more times just to take all the spring out of the system and get a nice clean finish. Okay, that looks great. Not quite, which is what we want. We want it to clamp. So I'm going to take out the parallel. And let's see how it fits. And that is beautiful. Now the next thing we need to do is take the rest of the material off of this side, and we're going to do this in a couple of steps. It would be theoretically possible just to come in here with a face mill and just take that all off. And if I thought I had a really good grip on the side, and if I thought these long overhangs were going to be rigid enough, I would do that. But I don't want to have an edge hook and lift up and get caught and rip the piece out of the fixture, because then we'll have to start all over. So what I'm going to do is I'm going to come in with a 1/4 inch end mill, and I'm just going to slot around the part. I'm going to leave 20 thousandths so I don't actually mill into the edge of the part, but I'm just going to come around and remove the top hat and get rid of all that excess material. I'm going to do that with a 3-flute 1/4 inch carbide specific, aluminum specific carbide end mill here. Torque that down. I'm doing a couple of things here to try to make this as safe as possible. One is I'm milling in a conventional direction so that the cutting forces will tend to take the excess material that's being cut off and throw it away from the part when it comes free, just to reduce the chance that it gets sucked in and jams. And then since I'm slotting, I'm going to be really careful and have some extra air on hand, just try to make sure that we don't get any chips packed up in the flutes. Okay, let's slot this out. Okay, looks like we've got a rim all the way around. However, the rim is wider on the left than it is on the right. So let me measure and see how far off we are. So we got 8 thousandths on that side. And 26 on that side. So I think what I'm going to do is I'm going to go ahead and continue with the decking operation, the facing operation, get this faced off. And then I will reset my coordinate system for the chamfers to make sure the chamfers are aligned properly. Now there's about 55 thousandths that have to come off of this, and I'm going to take 2 passes of 25 thousandths and 1 of 5 thou. And this face mill could easily take 100 thou at once, and at the right speed this mill could handle it, but I'm ever conscious of the fact that this thing is sitting in these soft jaws and I don't want it to pull out. So I'm going to take it nice and easy. I'm taking full extension passes for the best surface finish, though that really only matters on the final pass. This is the last pass of 5 thousandths, just to clean it up, make it pretty. It's already pretty. That is gorgeous. I love that face mill in aluminum. It just leaves such a beautiful finish. Just a complete mirror. I don't know if you can see that. Okay, so I need to move the coordinates. So what I'm going to do is I'm going to stop the program. I'm going to shift it slightly according to what I just calculated, and then come back and run just the chamfers. There's still a tiny little thread of a top hat. That was kind of the plan, to get the thickest part I possibly could out of a 3/4 inch piece of material. I did not want to have to come back in here and try to match up a cut on the top and bottom. So I took it far enough that the chamfer will absorb any of this excess material that's still hanging over. Now it looks like I do have hangover on all sides. Incidentally, I think I can see where I got my movement in X. I probably am clamped tighter and higher in Y, which moved the part this way slightly, which is exactly what we observed, about 1.5 thou. And I can see a small gap at this end, and there is no corresponding gap at this end, which means that the whole part has shifted this way a little bit in the soft jaws. And there is very little containing it on this side, and this edge is probably flexible. So that is likely the source of the error in this direction. So let me shift the axes and then we'll run the contour. Okay, off camera I adjusted the axes and then reposted the code, so I have a file for just the chamfer. Now what I did is I needed to move it that direction in the positive Y direction 1.5 thou. So what I did is I just moved it to positive 0.0015 position and then zeroed Y. And I need to move X 9.5 thousandths, so I moved it to positive 9.5 thousandths and then zeroed X. And that should put us in the right position now for the chamfer, and all we have to do is run it. I reposted the code, so I need to go grab that. And we should be ready to run. Okay, I can already see that that chamfer's not in the right place. It's coming out really thin on this side. I don't want to overcook it on the other side. Though that could just be due to compression and movement of the part itself. I think I'm going to go ahead and let it run. Yeah, I think the part is displaced out by squeezing it in the vise. So we get a little bit wider chamfer on the outside there. It'll be all right. Chamfer is consistent around this end, which means it's probably just a squeezed part. Oh, that's beautiful. Just remove the top hat all the way around. Now the chamfer is just a little bit wider on this end on the outside than it is on the inside. So it's supposed to be maybe a 15 thou chamfer, and we probably got 25 on the outside and 5 on the inside, but it's going to be okay. On this end, it's nice and consistent, so it must just be a squeezed part. Let's do one more thing to check that theory. If that's true, then the ring should not fit. If the part's distorted enough to do that, then the eccentric ring should not fit. And sure enough, it doesn't at all. And then when I release the clamp, release the vise, it should. Yep, and you can see when I release the vise, the part moved this direction, which is exactly what I was thinking. And that goes right in again. That's beautiful. That is going to be just fine. Okay, well, let's go over to the bench and take a look. Well, that is the motor clamp milled out of a solid block of aluminum, and I just could not be happier with how this turned out. The chamfers are beautiful. The finish that face mill leaves, I don't know if you can see this, but it is just a mirror finish. And the carbide end mill that I use on the edges, you can see just leaves, if you look at the inside of that bore, just leaves a mirror finish as well. And I just could not be happier with how that turned out. So let's check and make sure everything fits. We've got the eccentric ring. That straight, that just drops in. Spindle fits in, the motor fits into the eccentric, so we can ultimately put the pulley on and hook up the belt. And I just, like I said, I just couldn't be happier with how this turned out. There's a few operations left on this part. We need to drill 2 holes, countersink and tap for 1/4 28 clamp bolts. Then we need to come back with a slitting saw along this engraving line and split this so that we can allow it to clamp down. And we'll have to see exactly how this works. If we have trouble getting it to clamp, if it's not flexible enough to clamp on both sides independently, then we may have to make another slit in it just to separate it into 2 clamps. But I'm confident we can get this to work, and I'm just tickled to death with how well this turned out. If you're enjoying these videos, leave me a comment down below. Let me know what you like. Let me know what you want to see more of. Thank you for watching.